Perfect. Today I will present the application of laser beam welding and of course custodian technologies for the automotive exhaust system. As you all probably know, the laser beam welding is commonly used for the assembly of cars in many components. But until a few years ago, there was no product at all in the market of exhaust system joined by laser beam welding. But things drastically are changing in the last years, and so we started to see first products on the market of exhaust system built with laser beam welding, and we believe that actually this process will be the future for exhaust system. And in order to understand what happened that required the use of laser beam welding, we must look at the evolution of the car. Okay, that the car has changed a lot in the years. Of course, to compare the performances and the characteristics of the very old Fiat 500 from the 60s to the modern one would be too much. But what we can do and what is interesting to do is to compare the characteristics of the cars and how they changed in the last 20 years. So in order to do so, I compared the emission limits from 1999 compared with the emission limits after 20 years. So now, as you can see, in 1999, the Euro 2 regulation was ongoing, and there were no limits for the CO2 emissions. CO2, that means also the fuel consumption. And the average value was around 200 grams per kilometer. Now the limit is 95 grams per kilometer, so with an improvement of more than 50%. The CO emission, the limit 20 years ago was 1 gram, now it's 0.5. And so with improvement of 50%. The sum of hydrocarbons and NOx has improved by 76%, and the particulate emission is the more outstanding result because the emission has decreased by 94%. So the car now has improved a lot, but somehow I have to pay the bill of such green numbers here. And actually I see the bill in the weight, in the mass of the car. So I compared to average mass for the C segment. Just to understand each other, C segment is a vehicle as big as a Volkswagen Golf. And the mass of the car has increased by 17%. Of course, this mass increase is not is due to many factors, not just on the performances. It's also due to the safety increasing and to the comfort increasing. Nevertheless, it's a number that car makers are not happy with. They want to absolutely reduce the weight of the car. And the exhaust system has a role also in this mass increase. So let's have a look to the exhaust system evolution over years. In the 80s, the exhaust system was essentially made of few bended tubes, one central muffler, and a few brackets. Nowadays, the exhaust system is something extremely more complex. I just read as quick as I can the list of subcomponents of an exhaust system. So we have the DLC catalyst, the cross-coupled SCR catalyst, the cross-coupled mixer, the cross-coupled injector, particle filter, flexible joint, electrical heated catalyst, underfloor SCR catalyst, underfloor mixer, underfloor urea injection, central muffler, resonator, sensor probe, heat shield, dependent tubes, and that. So as you can see, it's extremely complex, and actually, if the exhaust system in the native was less than 10 kilograms, now it can be up to 50 kilograms. So the mass of the exhaust system now is not negligible no more, and car makers want to reduce, absolutely, it's a very important need to reduce the weight of the car and so also to reduce the weight of the exhaust. But since the complexity of such exhaust system cannot be reduced because all these subcomponents are absolutely necessary to match the regulation for the emissions, we must reduce the thickness of the materials involved in the construction of the system. And for this reason, the laser beam welding becomes absolutely useful. So finally, we can answer the question why laser beam welding has not been applied in the exhaust system in the past. First of all, because the standard welding processes, such as TIG, MIG, or MAG, were able to fit all kinds of applications in terms of dimension, complexity, fit. Then these kind of processes are characterized by higher tolerance in the subcomponents to be joined, and also by lower cost, I mean the cost of the equipment and the cost of the tool. But now, laser beam welding must be applied for the exhaust system manufacturing. First of all, because of weight reduction, I was saying before. In order to reduce the weight of the exhaust system, we cannot reduce the complexity, but we can reduce the thickness of metal sheet, going below 1 millimeter down to 0.6 millimeters. So with such thin thicknesses, standard welding processes are not good anymore. They would break through the sheet, damaging it. Just laser beam welding can deal such thin thickness. Then, moreover, standard products turn more complex. I showed you a picture before. And so the standard welding process might present some problems. For example, the torch of the MIG or TIG can have some problem in following the complex geometry of the exhaust system. So the large distance between the samples and the laser head becomes, which is typical of laser welding, becomes a key enabling feature. And last but not least, in recent years, some completely new and advanced products were introduced in the exhaust system. And these products are so complex and so advanced that actually they need an advanced welding process such as the laser beam. Now I will show you some examples, some practical examples of both weight reduction and new advanced products. So let's start from weight reduction. We made a case study on the silencing part of an 8-segment car exhaust system. The silencing part of the exhaust system is the final part. The exhaust system can be divided into two halves. The first is dedicated to the catalysis, and the second is dedicated to reduce the sound. And an 8-segment car is a small car, such as 500 or Panda or Yaris, or small cars. So these first two columns here show the thicknesses of the various subcomponents and the total weight, which is more than 12 kilograms. Then we imagine first this with the standard MIG or TIG welding process. Then we imagine a first scenario in which we introduce laser beam welding, so we can reduce the thickness of some subcomponents, and so we get a good weight reduction. And then a second scenario, a little bit more challenging than the first one that was a little bit conservative. In this second scenario, we further decrease the thickness of some components, and finally we get to very, very good 23% of weight reduction. That for car makers, this is a very good So some examples of prototypes that we developed in Marelli, for example, a stamped rear muffler in standard condition, the thickness of the bolt shell is 1.2 millimeters, but we were able to reduce them to 0.8 millimeters welding with laser welding, so a good weight reduction. Then a roller central muffler. In this case, we have two laser beam weldings, one overlap welding between the roller body and the final end cap, and also a butt welding along the axis of the roller body. And then also EGR pipe, where we use the T-butt laser welding to weld the tubes near to the so these were the examples of weight reduction. And now I will show you two examples of completely new and advanced products that are necessary for the future of the exhaust system. And this kind of products... Yes?
Sorry to interrupt, just that we are running out of time, so if you can then just try to wrap up, I'm sorry.
Okay, I quickly pass through these two examples. These are two examples of products. I will not go into the details, but these products are necessary to reduce the emission, the pollutant emission from the exhaust system. Both these projects, so the burner and then the thermoelectric generator I will show later, are quite small, are made of tiny subcomponents, very thin thicknesses, so they all need laser welding to be joined. So this is one, and this is the thermoelectric generator. Very quickly, there are three main requirements from the exhaust manufacturing for the laser beam welding. The first is, of course, the corrosion resistance of thermally alterated zone, because the exhaust system undergoes very hard thermal fatigue and thermal shocks and very high temperatures, and it is exposed to water and to outside conditions. So it's very important for the thermally alterated zone to be really corrosion resistant, avoid hot cracking, and to manage the gap between the parts to join. Actually, is a feature of this complex structure. It's an intrinsic feature. It's not easy to have a constant and thin gap between the parts to be joined. So the laser beam must be able to manage in constant and relatively large gaps between the parts. And actually, in the CUSTODIAN project, we are mainly focusing on this third characteristic. We use the technology of CUSTODIAN in order to be able to manage in constant and large gaps between the parts. So the first results from the project are very encouraging, also from the simulation point of view, and we're expecting to have very good results also at the end of the project. So I skip the conclusion that simply repeats what I already said, and thank you for your attention.